We're looking at problem 4 now in the Mod 7. This is optimization, and we're going to create a solver solution for the original problem we had in terms of projects in problem 1. So let's go to our workbook, and here's the problem. We want to set up the problem in problem 1, which we stated in terms of a linear program in this fashion. So we want to solve that problem. How do we solve that? Well, we need to create that table input for the purposes of solving our problem. I have an area up here that's generally dedicated to the objective function, and then down here to the constraints. But I've also got some constraint information up here. I'll show you what I'm doing in just a second. So here's the all-important cell, the golden cell. This is the value of the objective function. Let's go to our, by the way, these are the coefficients for the variables, the project, the number of project 1, the number of project 2, 3, and 4 that we're going to accept. Currently, they're all set to 1 just as a dummy set of values, and the program will determine what these should be and how to maximize this objective function. Let's go to our solver. I'm going to get rid of this. This is the solution, but I'm going to delete it. And start from the beginning. So we set our objective as the golden cell. We want to maximize, so we hit that. I could have minimized, but we're maximizing this problem. The changing cells are here. This is where the program is going to determine the values of the number of projects that it's going to accept. And then finally, I need to add my constraints. Recall I've got 8 constraints. 4 of the constraints are related to the maximum number of projects that can be accepted. And then we have resource constraints that say every time you accept a project 1, you use 3 units of resource A. You accept a unit of project 2, you use 9 units of resource A, etc. And you have no more than 450 units of project A resource available to you. So the right-hand side is, the left-hand side is calculated here. This is the sum of the quantities that are going to be determined from the use of variables. This is 3 plus 9 plus 3 plus 4 gives us 19. I'm going to get out of this for just a second. You can see that the function in here is the sum product of the number of variables times the units selected, or the resource units utilized for each variable. So if I had a 2 here, rather than multiplying 3 by 1, I'd be multiplying 3 by 2. Let's go back to solver again. I've already got the information for the changing cells for the objective function. Now I want to add constraints. I'm going to add the constraints related to the maximum number of projects that can be accepted. So the left-hand side, the number of projects that are accepted, has to be less than or equal to the right-hand side, which is, excuse me, I've got to move my cursor over here to this cell, 25. This value cannot exceed 30. I can't accept any more projects for 3 more than 47. And then finally, for project type 4, it's got to be less than or equal to 53. I keep adding now constraints. I've got 4 more constraints to add. The left-hand side is here. This is how I accumulate my resources used, and it's got to be less than or equal to 450. Here's my left-hand side. It's got to be less than or equal to 490. Here's my left-hand side. It's got to be less than or equal to 360. And then finally, for resource D, the accumulated use of resources cannot exceed 285. And here are my constraints now. My constraint set, I'm using the simplex method. This is what I use for LP, the simplex method. Hit solve. It says, yes, I've got a solution for you. I'll want to keep the answer and the sensitivity information, so I can then save my data. And we can see that the solution to the problem here is 25 projects 1, 30 projects 2, and 25 projects 3, no projects 4. And that by using that combination of variables and the constraint set that I had, I get a objective function value of 3,565,000. Notice that I did this problem outside the workbook. I'll show you why I did that later, and then we'll just paste this back into the workbook. We could have done this solution in the workbook, but when we're doing the sensitivity analysis, I have to remove this problem from the workbook because the sensitivity analysis is not like the fact that there are multiple linear programmings going on at one time in the workbook. So here's my solution. The objective function is 3,565,000. The values of the projects that are selected are here, and I also have information relating to constraints that are binding and non-binding, and I also have information related to the sensitivity report, and we'll talk about that next. That's the end of part A of the LP for Solver.